This is lesson 7-E using exponent properties. We're going to simplify expressions containing integer exponents. Example number 1. We have n to the third times n squared to the fourth. Notice we will use multiple properties in these examples. Identify what property we will use first. We'll start with the n squared to the fourth. That's a power to a power, so we will multiply. So we have n to the third times n to the 2 times 4th, which gives you n to the 8th. We'll now need to add the exponents since we have like bases. So we have n to the 3 plus 8, which gives us n to the 11th. We will see why these properties work. You do not have to copy this information down. It's just helpful to give you a further understanding of the exponent properties. Example number 2. We have 10w squared over 5w to the 6th. First, we'll need to reduce the fraction. We have 10 over 5, which both are divisible by 5. 5 can go into 10 2 times, and 5 goes into 5 once. Now look at the exponent properties. Notice we have property number 7. We will subtract our exponents 2 and 6, which gives us a negative 4. Notice we have 2 times w to the negative 4th. The understood denominator of a 1 does not have to be written. We'll have to continue to simplify using property number 2. We have a negative exponent in the numerator, so we can change that to a positive by flipping it to the denominator. Notice the 2 stays in the numerator because it did not have the negative exponent. So our final answer is 2 over w to the 4th. Again, to see why this property works, you do not have to copy it down. It just helps give you a further understanding of the exponent properties. Example number 3. X to the 5th times xy squared. The exponent property we will begin with is for the part that says xy squared. That will be property number 6. We apply the exponent to both the x and the y. Remember, we said this is not the distributive property. We're applying the exponent to each factor. So the x is squared and the y is squared. We must continue to simplify to get rid of the like bases. We have the exponent property that says we can add the exponents when we have like bases. So 5 plus 2 gives us 7. So our final answer is x to the 7th y squared. Again, to see the further understanding of why this works, you do not have to copy this down. Example number 4. We have d over c all raised to the negative 4th power. Here we'll begin with property number 9. We take the reciprocal of the fraction and change our exponent to a positive. We must continue by using property number 8. Apply the exponent to both the numerator and the denominator. So the c to the 4th over d to the 4th. Notice we will stop here and let it be our final answer. We cannot use property 7. It says we must have like bases in order to subtract the exponents. Again, to see Why it works just helps further your understanding of the exponent properties. Example number 5. We have 4s over 8t all raised to the third power. Begin with first reducing the fraction. 4 and 8 are both divisible by 4. 4 goes into 4 once, and 4 goes into 8 2 times. We now see that we can use property number 8. Apply the exponent to everything in the parentheses. A 1 to the third power would just be 1, so it's not necessary to write. The s gets the third power. The 2t gets the third power. You could go ahead and use property 6 at that same time and showing the 2 to the third and the t to the third in the denominator. 2 to the third is 8, so we will simplify that part of our answer. So our final answer is s to the third over 8t to the third. Example number 6. We have q to the third over q to the third. Here we see that we have property number 7. We have like bases, so we will subtract their exponents. 3 minus 3 gives us 0, but anything to the 0 power is 1. So property number 1, anything to the 0 power equals 1. But take a look at the beginning problem. Q to the third over q to the third. Anything divided by itself equals 1. Example number 7. We have 1 over 2 to the negative third. We'll begin with property number 3. We have a negative exponent in the denominator, so we can move that to the numerator to make the exponent positive. 2 to the third equals 8. Example number 8. I have x to the negative 7th over x to the negative 6th. You could start with property number 2 and 3 to simplify the negative exponents. However, I'm going to start with property number 7 that says when I have like bases, I can subtract the exponents. So negative 7 minus a negative 6. Be careful and add the opposite. This gives you negative 7 plus a positive 6, which is negative 1. We will need to use property number 2 to simplify the negative exponent. The negative exponent is in the numerator, so it will flip to the denominator as a positive. So we have 1 over x to the first, which the first as the exponent does not have to be written. Again, exploring why this property works, you do not have to write it down. Example number 9. We have f over negative 2, all raised to the negative 4th power. Here we will start with property number 9. It says we will take the reciprocal of the fraction and change the exponent to a positive. Notice when we change the fraction, it does not change the negative 2. It only changes the exponent, the negative 4, to a positive 4. Now use property number 8 to apply the exponent to both the numerator and the denominator. The negative 2 to the 4th power and the f to the 4th power. The negative 2 must be in parentheses. If you ever want a negative base, include parentheses around the number. Negative 2 to the 4th power is a positive 16. Over f to the 4 is our final answer. If you use the calculator and it gives you a negative 16, that means you did not use parentheses in the calculator. Example number 10. We have m squared over 5n all raised to the third power. We will start with property number 8. Apply the exponent to each part of the fraction. So the m squared gets to the third power, the 5n gets the third power. You could go ahead and use properties 5 and 6, multiplying a power to a power and applying the exponent. So first in the numerator, a power to power you multiply. In the denominator, applying the exponent, the 5 gets the third power and the n gets the third power. So our final answer is m to the 6th over 125 n to the third. We cannot go any further and simplify by subtracting exponents because we do not have like bases. Example number 11. We have y to the negative 7th times y to the 4th. You could start with several different properties. I'm going to start with adding the exponents. If you would like to simplify first by changing the negative to a positive, it will also work. Negative 7 plus 4 gives us a negative 3. We will now change that negative to a positive using property number 2. So we will have 1 over y to the third. Like I said, if you wanted to change the negative to a positive from the beginning, you could have written the y to the positive 7th in the denominator. Example number 12. Well, anything to the 0 power is 1. So our entire answer here just equals 1. That concludes Lesson 7-E, Simplifying Expressions Containing Integer Exponents.